Hello, everyone, and welcome to this lecture on artificial intelligence. My name is Akshay Bhuneshwari Ramakrishnan, and in this series of lectures, we will follow one of the most widely used textbooks in AI education, Artificial Intelligence, a Modern Approach by Stuart Russell and Peter Norvig. And this book is available to freely download in the internet. And this book forms the foundation of many AI courses around the world, and it provides a structured way to understand what intelligence is and how we can build intelligent systems. Artificial intelligence is one of the most exciting fields in computer science because it tries to answer a very deep question. Can a machine thinks and act intelligently? AI is not only about building useful technology like chatbots, recommendation systems, or autonomous vehicles. It is also about understanding the nature of intelligence itself. So, to begin exploring AI, we will first need to answer a fundamental question. What is artificial intelligence? That is what we will discuss in this section 1.1 of what is AI. So this chapter is foundations of AI. So the field of artificial intelligence tries to do two main things. First, it tries to understand what is intelligence. Second, it tries to build machines that show intelligence. So AI is both a scientific field that studies intelligence and an engineering field that builds intelligent system. Now, the difficult part is defining what intelligence actually means. Different researchers have proposed different definitions for AI, but Russell and Norvig explain the most definition of AI fall into four categories. These definitions are based on two important ideas. The first idea is about how we measure intelligence. Some definitions compare machines to humans. Other definitions compare machines to ideal makers. So, this ideal decision maker is called a rational agent. Now, let's understand the word rational. A system is rational if it makes the best possible decision based on the information it already has. In simple words, a rational system tries to do the right thing given what it knows. The second idea is what we focus on. Some approaches focuses on how machines think internally. Other approaches focuses on what machines actually do. When we combine these two ideas, we get four approaches to AI. So Russell and Norvig divide AI definitions into four main approaches. These approaches come from combining two questions. First question, should machines behave like humans or should they try to make the best possible decisions? Second question, should we focus on how machines think or how machines act? When we combine these two questions, we get these four approaches. So let's discuss these four approaches in detail. And this might be your 2 mark or 4 mark questions if you are taking this course. This the first approach is thinking humanly. This means trying to build machines that think the same way as humans think. The second approach is acting humanly. This means building machines that behave like humans, even if their internal process is different. The third approach is thinking rationally. This focuses on logical reasoning, how to reach correct conclusions using rules of logic. The fourth approach is acting rationally. This focuses on building systems that make the best possible decisions to achieve goals. So in modern AI, the acting rationally approach is most widely used. But historically, all four approaches have played an important role. So let's start with the first approach, acting humanly. One of the most famous ideas in AI is the Turing test. proposed by the British mathematician Alan Turing in 1950s. So Turing asked a simple question: how can we tell if a machine is intelligent? Instead of defining intelligence directly, he proposed a test. So in this test, a human judge communicates with two participants using text messages. So both these participants are behind the screen. So one participant is a human and other participant is a computer. The judge asks questions and reads the answers. If the judge cannot reliably tell which participant is the machine, then the machine is set to pass the Turing test. The idea is simple. If a machine behaves like a human in conversation, we may consider it intelligent. This approach focuses only on behavior. It does not care how the machine thinks internally. It only asks, can the machine act like human? So to pass the Turing test, a machine must have several important abilities. The first ability is natural language processing. This means the machine must understand and generate human language. For example, it must understand questions and produce meaningful answers. The second ability is knowledge representation. The machine must store information about the world. For example, facts, rules, and relationships between objects. The third ability is automated reasoning. This means the system must use its knowledge to answer questions and make conclusions. For example, if it knows that all humans need oxygen and that a person is human, it should conclude the person needs oxygen. The fourth ability is machine learning. Machine learning allows the system to learn from experience. Instead of being programmed for every situation, it can improve over time. These four capabilities form the core components of many AI systems. The original Turing test only evaluates conversation. However, human intelligence involves more than language. Humans also see the world and interact physically with objects, right? So to test these abilities, researchers propose the total Turing test. So this extended version includes two additional capabilities. The first is computer vision. Computer vision allows machine to understand visual information, for example, recognizing objects, detecting faces, understanding scenes. The second capability is the robotics. Robotics allows machine to move and manipulate objects, for example, picking up object, walking, navigating through environments. So the total Turing test requires a machine to combine language, perception, reasoning, and action. We will speak about these keywords that I just mentioned in detail in the following chapters. So this makes the challenge much harder. Now let us clearly understand the difference between these two tests. In Turing test, the judge communicate with the machine using only text messages. The machine does not need to see or interact with physical world. The test focuses mainly on language and reasoning. In contrast, the total Turing test also includes perception and physical interaction. The judge can see the subject and may give objects to manipulate. Because of this, the machine must have computer vision, robotics. So we can summarize the difference like this. The total Turing test measures complete intelligent behavior, including perception and action, whereas the Turing test measures conversational intelligence. The next approach is called thinking humanly. This approach tries to build machines that think the same way humans think. To do this, researchers must first understand how thinking works. Scientists study human thinking using several methods. One method is introspection. This means observing our own thoughts and mental process. Another method is psychological experiments. Researchers observe how people solve problems and make decisions. A third method uses brain imaging technologies, which allow scientists to observe brain activity. So once researchers develop a theory of human thinking, they try to implement that theory as a computer program. If the program behaves similarly to humans when solving problems, it may be a good model of human thinking. The research led to a field called cognitive science, which combines AI, psychology, neuroscience, and linguistics. The third approach is called thinking rationally, also known as the laws of thought approach. The approach focuses on logical reasoning. The idea comes from the ancient Greece philosopher Aristotle. Aristotle studied patterns of reasoning that always produce correct conclusions. These reasoning patterns are called syllogisms. For example, all men are mortal. Socrates is a man. Therefore, Socrates is mortal. If the statements at the beginning are true, the conclusion must also be true. Researchers believe that if we could represent knowledge using logical rules, computers could use these rules to reason correctly. However, this approach has two major difficulties. First, real world knowledge is often uncertain and complex, which makes it difficult to express in strict logical form. Second, logical reasoning with large amount of knowledge can require enormous computational resources. Because of these difficulties, this approach alone cannot solve all AI problems. The final approach is called the rational agent approach. This is the approach used most widely in modern AI. First, let's understand the word agent. An agent is anything that perceives its environment and takes action. For example, a robot, a self-driving car, a software program, even a human. A rational agent is an agent that takes actions that maximize the chances of achieving its goal. In simple terms, a rational agent tries to choose the best possible action. Sometimes the environment is uncertain. In those cases, the agents choose the action that gives the best expected outcome. This approach is more general than the earlier approaches. It does not require machines to think exactly like humans. Instead, it focuses on making good decisions. Because rational behavior can be defined mathematically, this approach is easier to study scientifically. For this reason, modern AI systems are defined and designed using the rational agent framework. So most modern AI systems, including machine learning models, robots, and autonomous vehicles, can be understood as rational agents interacting with their environment. And next, we will look into 1.2, the foundations of artificial intelligence, in our next video. Thank you.